Hello friends, I welcome you all for my first presentation on DSAT, a crop growth simulation model. So friends, as you all know that there are different crop growth simulation models which are available throughout the world. To name a few, APSIM, InfoCrop model, CropSys and DSAT. Among them, DSAT is one of the essential and important decision making tool which has been widely used throughout the world in different climate change and its impact analysis studies, yield prediction, yield gap analysis, and also optimization of different agronomic management practices or agro input under different scenarios. So friends, DSAT is been in use for last 30 years by more than 14,000 researchers, educators, consultants, and extension agents, growers, policy and decision makers in an over 150 countries throughout the world. Therefore, in this presentation, I would like to cover in brief about this important crop growth simulation model with respect to what is DSAT, what is the brief history of this DSAT model, then what are the different components which are there in a DSAT model, then what are the different modules which are existing in this DSAT model, and also about management tools which are there in this DSAT model, then also important applications of this DSAT model, and finally how we can download this DSAT model for further usage in our research activities or research component or research programs. So friends, I will start my presentation with first slide, that is what is DSAT. DSAT is a decision support system for agro-technology transfer. It is a computer-based software program that comprises of different dynamic crop growth simulation models. So it is mainly used as a research tool for crop production analysis. So it also helps for collection of independent programs that operate together. Crop simulation models are at its center. So it incorporates the modules for crop, soil, and weather to simulate a long-term outcomes of a crop management strategies. So friends, in nutshell, DSAT is a collection of independent programs that operate together, and crop simulation models are at its center to simulate a long-term outcomes of a management strategies. So DSAT is designed to allow users to adapt, evaluate models for their own conditions, and it also incorporate their own data into standard formats and provide insight into different questions which are arised during the crop production processes, especially the profitability and stability of the different crops and crop production processes. And it also helps for the researchers to understand the responses and interactions that occurs in the field, especially for plant breeders to know the genotype into environmental interaction, and for agronomist, soil scientist, and the physiologist, which helps to know the what is exactly going on between the soil, plant, and atmosphere. Next, coming to the brief history of this DSAT model. So before development of this DSAT model, or during 1980s, there were individual crop models were there. For example, the for cereals, ceres model was there, and for soybean it's SOYGRO, and for groundnut PNUTGRO model were there. So these models, or the individual models, programs, or the softwares having its own soil, crop, and management, as well as the weather components. And also the major difficulties was observed by the many of the researchers, or the crop models throughout the world, was the compatibility and maintenance issues, and also addition of the new crops to the existing one. So this has led to creation of a DSAT model. So the group of scientists who were working in this international benchmark site network for agro-technology transfer, that is IBSNAT project at University of Hawaii, USA, they have developed this DSAT model for initially 4 crops, that is for maize, wheat, soybean, and groundnut. So they have released this DSAT version 2.1 in the year 1989. After that, they have modified this DSAT model, and they have added different component to this DSAT version 2.1, and they have released the several versions year after year. And currently, the DSAT 4.7.51 is available, and it is being used for the more than 40 crops throughout the world. So there are Some of the important scientists who were involved in development of this DSAT model are the Professor J.W. Jones and Professor Hogenboom and Professor Boote. Several other international scientists as well as the international organizations were involved to bring this DSAT model at user-friendly level. So coming to the important component of this DSAT model, first one is the database and a model application part and also the supporting softwares. All these together formulate the DSAT user interface. So this database describe the different weather parameter, then soil condition, and also the crop genetic information, and the pest and disease parameters, and also experimental condition and the economic parameters. So this helps for applying the models in different situation with the help of these databases. So this different modules which are there in the DSAT I will discuss in my next slide. So the next one is the supporting softwares. So this supporting software mainly help for users to prepare this database and compare the simulated results with the observed ones to give them a confidence in model, or to determine if any modifications are needed to improve accuracy of this model. So these are the some of the supporting softwares that are existing in this DSAT model, that is graphics, weather, soil, experiment, pest, genetic information, and as well as the economic parameters. Then coming to the application part, that is validation, or the sensitive analysis, seasonal or statistical analysis, crop rotation sequence analysis, then spatial analysis or JS linkage. That I will discuss this application part in the next slides. So all these database model, different crop models, supporting softwares, and application part constitute to form a DSAT user interface. Then these are the different crop models which are there in this DSAT cropping system model. So the first one is the crop grow model. This crop grow model is mainly for the leguminous crop, and also for the some of the vegetable crop and pasture crop, and also for the cotton crop. Then the CERES model for the all the cereals as well as some of the millet, and this substore for potato, cane grow for sugar cane, and aloho for pineapple, and also some of the other models are also existing in this DSAT model. So these are the other main models which are existing DSAT model in addition to the different crop models. So that are the soil, environment, soil, plant, atmosphere management, and pest and diseases. So within this soil model, the water, temperature, carbon, nitrogen models are there. So these phosphorus and potassium models are recently added to this DSAT cropping system model. Then coming to the different data management tools. So first one is the XBuild, that is experimental build. So it is consist of different input crop information in a standard format. Then the next one is the SBuild, or the soil build, which helps for creation and the editing of the existing soil profile in the DSAT. So the next one is the GBuild, or the graphical display. So it's help for the display of graphs for simulated as well as the observed datas. Then A file, T file creator. So it helps for the creation and editing of the observed the data, especially the whatever the data which we take during the experimentation, that we can enter in this A file or T file to express in standard format. Then next one is the weatherman. This is the help for the users to cleaning, formatting of generated weather datas. The next one is the IC simulation, or introductory simulation, to demonstrate the potential yield concept. Then the next one is the sensitive analysis. So this DSAT model is very sensitive for the different soil fertility level as well as the different weather parameters such as the solar radiation, temperature, and the rainfall. And it is also sensitive for the some of the management practices, especially the days to the planting date, and so nitrogen, and the some of the water management practices, that is water management practices, and also the varietal characteristics. Then seasonal analysis, so it explains the multiple year simulation to evaluate uncertainties which are comes during the crop production processes, especially the biophysical and economical responses. Then next one is the rotational or sequence analysis. So it is the long term simulations to analyze the change in productivity and the soil condition which are associated with different cropping systems. Then the spatial analysis, which defines the spatially variable soils, and the weather and also management characteristics across a field or a region for analysis. So this spatial analysis is mainly helps for the introduction of the new crops to new area, and also for the evaluation of the different genotypes or the varieties in different locations, and also soil fertility evaluation in different locations across the region. So after installation of the DSAT model, when we click on this DSAT icon, then you can first that will open will be the user interface that looks like this user interface. So this interface is consist of the different management tools, such as the crop management data, then graphical display, then soil and experimental data, weather data, seasonal analysis, rotational analysis, then genotype coefficient calculators, some of the shortcut keys and references, important references, then utilities, and also the accessories. So this management crop management data includes the when we click on this crop management data, so it will open the xbuild file. So this xbuild file, as I said, it is consist of the different the input information, as well as the different management practices, and also the different the input files, especially the soil file, met file, and also the treatment components, and also the crop the simulation options, also the existing this crop management data. Then the graphical display. So this graphical display will help for the displaying of the observed as well as the simulated data in through graphs, as well as the weather data. Also we can express through this different graphs. Then soil data, this will help for the creation of the soil profile for new locations, and also we can edit the existing soil profile data in this DSAT model. Then experimental data, so this is the mainly for creation of a file as well as the t file. So whatever the data which we take during the experimentation, that we can enter with the help of this a file and t file with the help of this experimental data. Then the weather data, so this is mainly for the importing of this observed weather data as a input file for this DSAT model, and also help for the creation of the met file. Then seasonal analysis is mainly for long-term evaluation of this crop production analysis with respect to the biophysical and economical responses. Then rotational or sequence or cropping system analysis is mainly for to evaluate the cropping system, different cropping system effect on different soil fertility studies. Then the genotype coefficient calculators, mainly for the genetic coefficient calculations. Then this my shortcut keys also there in exist in this my shortcut, and the references, the important references are also there in the some of the latest version DSAT model DSAT version references are there in this reference section. Then utilities, So this utilities consist of the configuration, explorer, and also version information. Then next one is the accessories. In accessories, it is consist of the introductory simulation, that is for yield gap analysis. Then for it also consists of the glue, that is generalized likelihood uncertainty estimator for genetic coefficient estimation. And also consists of the easy grapher, that is for statistical evaluation of the experimental data, as well as the that is observed as well as the simulated datas. And the next one is the sensitive analysis. As I said, the model is sensitive for the planting dates, then some of the agronomic inputs such as nitrogen and water, and also the certain weather parameters. Then next comes to the within that again the weather analog is also there. This weather analog is mainly helps for when you have a single year weather data or multiple year weather data, how we can simulate this DSAT model. So here we have the different crop models. So whatever the X build we create, that will come in respect to crop file, so crop models. So again this is application part, that is seasonal, sequence, and spatial, that all the files will be created in this the seasonal, sequence, and the spatial one. Then data, the whatever the input data which we needed for this DSAT model, that will be comes here. Then pest information, and as well as the some of the standard data are also exist in this DSAT standard datas. Next is the coming to the application part of this DSAT. So the DSAT model is used in a wide range of application at different spatial and as well as the temporal scale. So which is mainly used for the diagnosis of the different problems, and also helps for the yield gap analysis, as well as the yield prediction, and also optimization of the different agronomic management practices, and also the precise management of the different agronomic management inputs or agronomic inputs, especially the water and irrigation. And also helps for it is also applied in the different soil fertility evaluation or soil fertility management. Then this model is also help for the plant breeders to know the genotype into environmental interaction, and also yield prediction under different crop management practices. And it has a significant role in the climate variability and risk management, and also the climate change and its impact studies. And also the long term effect also help for the carbon sequestration in the long term studies, and also the nitrogen balance in different crops and cropping system for a long term studies. And also helps for the risk insurance, that is the also help that is for impact analysis of the rainfall, the both drought as well as the flood impact analysis on crop yield. Then how much yield is affected due to the drought or the flood. So that data we can the yield loss data we can give to the insurance companies also. And these are the some of the important applications of this DSAT model. And next one is the how we can download this DSAT model for our further usage. So the link which here I'm giving, you just type this link in the Google, so that will open the DSAT website. And in that website it will ask you to enter the active email, your active email address. So just you type your active email ID here, and then submit to DSAT group. So within 1 week we will get the link of this DSAT software current version 4.5.7. So that 4.7.5 version along with the user ID. So after clicking of that link, that the DSAT model will be downloaded. So after installation, and just you enter that ID they have provided, and then it will start for further usage in your research work or the research activities or research component. So friends, that's it for this presentation. So in my next presentations I will be covering in brief about what are the minimum data set which are required for this DSAT model, and also how we can create the different input file for the DSAT crop growth simulation model, and also how we can develop this X build file, and also the important part, that is calibration and validation of this DSAT model, and also the conducting of some of the experiment in the DSAT model, and also I will give complete hands-on training with the help of these presentations, how we can how exactly we can use this the different data management tools which are there in this DSAT model and all. So so with this I would like to thank you all for patience hearing as well as the listening hearing of my presentation. Thank you one and all.